Hello everyone and welcome to this my video on expanding and simplifying polynomials. Oh god, this gets more exciting as we continue. Now my name's Darren from Maffs Guru. Yes, I thought that was a great idea in 2013. I thought it was so funny, but apparently not. Because I just have to spell it all the time. But why am I telling you this? Because actually if you head over here at this moment in time, what can you do? You can download the lesson notes that I'm about to write on all over behind me. Now why would you possibly want to download them? Well, who's to say that I write down everything that needs to be or everything you need to, all right? It's absolutely free to sign up and there's so much stuff on there. Trust me, loads and loads and loads. And as you get towards your VCE and later on there are exam questions and interactivity and all sorts of stuff that might be helpful, free to sign up. Absolutely. Right, let's get on to the actual lesson. Now, I'm building on the stuff I've done previously, but I always start with the learning objectives. Let's see, we're going to understand, be able to apply the rules of expanding brackets to multiply polynomials. And I know you're already shuddering, aren't you? Why? Because we've already done expanding brackets to death with quadratics. Well, that's okay. If you've learned how to do it with quadratics, you can apply the same learning. Sort of. Depends how you were taught. Let's see where we go with that one. To understand that multiplying polynomials results in a polynomial of a higher degree. What do I mean by higher degree? Am I going to university already? No. Have you watched my previous video on introducing polynomials? No. Well, it's on mathsguru.com again, and also, believe it or not, YouTube. What is this YouTube we are talking about? Come to that in a moment. All right, so here's a recap of the past learning. If you don't know what I'm talking about, I actually have a YouTube channel. If you can subscribe to it, that would be great. You might be watching this on YouTube. Subscribing it means the absolute world to me. Yesterday, I posted videos for year 10 content and I lost 25 subscribers. Why did I lose 25 subscribers? It's the start of the year and all of the people who subscribed last year were like, yeah, now I'm not doing maths anymore, and sort of just dumped me, and it hurts a little bit. So those 25 people, I'm so sorry to see you go. But if you subscribe, turn off notifications if you don't want to be, told that I'm around. It just means that you've told me you're watching. Anyway, so this video is there, or the video that I'm talking about is there to watch as well. Now, it's important for both year 10, 11, 12 to understand the language of polynomials, so understand the language that we use, because that's where we tend to trip you up, particularly if you're going to do methods. So, degrees of polynomials is probably the one that we're going to deal with the most at this moment in time, and that has a degree 8. Why? Because it's the highest floating number, all right? Now, again, in my previous video, I told you that normally we put them in order, don't we? We put the highest floating number, then the next floating number, and the next floating number, but we can trick you. We can write them in different orders. Why? Because of that. It tests your understanding rather than are you just regurgitating. So degrees of polynomials is useful. Leading terms, coefficients, pronumerals, constants. Just be aware that algebra for this whole topic is really important. And if you suck at algebra, don't worry about it. The more you do, the more mistakes you make, the more you turn around and go, huh? You will get better. And suddenly all that stuff that's in your brain that you're trying to undo, yeah, you'll be able to smash it. I promise. I hated maths at school. And now look at me. I talk to myself in a room on my own. That's actually really depressing and not an advertisement for anything. Right, here we go. So expanding brackets. Now, as I told you, we've been dealing with this with FOIL previously, haven't we? Yes? With quadratics. And if you had me as a teacher, one of the methods I showed you was FOIL. Now, what on earth did FOIL stand for? Well, if we do a quick example, let's try and write one down here. If I do x plus 2 multiplied by x plus 3. Now, the first thing I need you to realize is we need to start thinking this in terms of... what am I thinking? In terms of highest floating numbers or degrees or what each of these could be. So these are actually what we call linear factors. Why? Because the highest floating number there is a 1. And if you remember from the previous video, we had linear, we had quadratics, cubics, quartics, quintics, and so it goes on. So we would say here that this is the product of two linear factors. Why? Product is timesing two linear factors. Now, what would we do with FOIL? Well, if you remember again from the teaching that I might have done you, that would go x times x. So first you do the first two. What do you do then? First two. And then the outside ones. So that's the x and the plus 3. And then the inside. And then the last. That is FOIL. There is a pattern. Now, I never at school thought of it as FOIL. I just drew the pretty arrows overwards. It made sense. Now, what I was taught at school was something slightly different. Same idea, but probably much, much better. So let's do this here now. All we told, I started the first term of the first linear or the first bracket, and I multiply every term in the second bracket by the first one. So that's all I was doing. I was taking this x and I was multiplying it by x first then, and then I was sticking with the x and going with the plus 3 then. Having done that, I moved to the second term and I did the second times the first and the second times the second. Now the reason that actually makes more sense is because when we get to an example like this here, what do we notice? Well, we don't have two terms in each brackets. Here I have the product of two quadratics. Yeah, so there's two quadratics there that I'm